You ever look at two computers? They've got the same clock speed, but one just feels way faster than the other. What's the secret sauce? Well, a lot of the time, the secret weapon isn't the cores or the gigahertz. It's this hidden layer of memory called cache. So today, we're going to break down exactly what L1, L2, and L3 cache are and why they're so incredibly important for a fast computer.
All right, so before we dive into what cache is, let's talk about the problem it's actually trying to solve. And honestly, it all boils down to a waiting game.
So here's the crazy thing, right? Your computer's processor, the CPU, is an absolute beast. It can perform billions of calculations every single second. But here's the kicker. A lot of the time, it's not actually doing anything. It's just sitting there, waiting around, waiting for data to come all the way from your main system memory, your RAM. And that delay, that long trip to get data, is pretty much the single biggest bottleneck in all of modern computing.
So, how do you solve this waiting problem? Well, the best way to wrap your head around it is to forget about computers for a second. Instead, let's imagine a really busy, high-end professional kitchen. Trust me, it'll make perfect sense.
Okay, so the technical solution is called CPU cache. All it is really is a tiny little chunk of super-duper fast memory that's built right into the processor itself. Its whole job is just to hold a copy of the data the CPU is going to need again really soon. But, that's the textbook definition. What does that actually mean?
Let's go back to that kitchen. I want you to imagine your CPU is a master chef. He's got orders flying in, and he's trying to get those amazing dishes out as fast as he possibly can.
So in this picture, right, the chef, that's your CPU. He's the one doing all the heavy lifting. The ingredients he needs to cook, that's your data. Now the main ingredient storage is this huge warehouse out back. That's your RAM. It's got everything, but man, it's a long walk to go and get something. But the cache, that's like a fridge placed right next to the chef's station. It's small, sure, but it's stuffed with all the ingredients he uses most often. This means he can just reach over and grab what he needs, making everything so much faster.
But here's where it gets even cooler. It's not just one fridge. To make this kitchen super efficient, the cache is actually broken down into a hierarchy of different levels, L1, L2, and L3. And each one has its own special balance between size and speed. Let's start with L1, or Level 1 cache. This is the absolute fastest, but also the smallest. Think of it like a little spice rack right on the chef's countertop. I mean, he doesn't even have to move his feet. The salt, the pepper, the key spices, they're right there, literally at his fingertips. It's tiny, but you just can't beat that instant access.
Okay, next up is L2 cache. This is like a small mini fridge right under the counter at the chef's station. It's bigger than the spice rack, right? So it can hold more stuff, like the chopped vegetables, the sauces, things like that. It's still super close and really fast to get to, just a quick step away. But yeah, it's a tiny bit slower than just grabbing a spice.
And finally, you've got L3 cache. Now this is the big one. It's like the large, shared, walk-in fridge for the entire kitchen. Modern CPUs have multiple cores, which is kind of like having multiple chefs working at once. And all of them share this one big L3 cache. It's way bigger, it holds a ton of different ingredients, but it's a bit of a walk to get to. So it's the slowest of the three cache levels, but still way, way faster than going out to that warehouse.
So let's just put that all together. You can see L1 is tiny. We're talking kilobytes here, but it is lightning fast. L2 gives you a bit more breathing room, maybe up to a couple of megabytes. And then L3 is the big pool of memory. You're looking at 8, 16, even 64 megabytes or more these days. And you see the trade-off, right? As you get bigger, you get a little bit slower. It's all about finding that perfect balance.
Okay, so fridges, spice racks, chefs, it's a fun way to think about it. But what does this actually mean for you when you're just using your computer every day? Why should you even care about all this technical stuff?
Honestly, the difference is night and day. Without a good cache system, your CPU is always making that long, slow trip to the RAM warehouse. And what that feels like to you is apps feel sluggish, trying to multitask is just painful, and games, they'll stutter and lag. But with a good cache, the CPU gets what it needs almost instantly. And that translates into everything feeling smooth, snappy, and responsive. Gaming is a perfect example of this, in action. Think about it. The second you press a button on your controller, that instruction needs to be handled instantly. That's a job for the super fast L1 cache. Then you have things like enemy movements or physics calculations. That's probably living in the L2 cache. And what about the big stuff? The data about the game world itself, that all the CPU cores need to see. Well, that's parked in the big shared L3 cache. It's this beautiful teamwork between the different levels that gives you that smooth, lag-free gaming experience we all want.
Okay, let's bring all of this knowledge home. The whole point of this is so that the next time you're shopping for a new laptop or a CPU, you can look at the spec sheet and actually understand what you're looking at.
Now, it's not all perfect. The pros are pretty clear, right? You get a huge speed boost, everything is more efficient. But there are cons. For one, cache is really expensive to make. It's a much more complex type of memory than RAM, so it adds to the cost of the CPU. It also uses a bit more power. And that's exactly why companies can't just slap hundreds of megabytes of cache on every single chip. It's a balancing act.
So from now on, when you're browsing for a new computer and you see something like 32 megabyte L3 cache, you're not just going to see a random number. You'll know what it means. You'll understand that it's talking about the size of that kitchen's walk-in fridge, which tells you exactly how efficiently that little chef, the CPU, can do its job. It gives you a real clue as to how fast that computer is going to feel. Because at the end of the day, it's not just about how fast the chef can cook, it's about how well-stocked his kitchen is.